friends, my name is Suchi Dubey and welcome to my YouTube channel. Today we will learn how to identify outliers in your dataset by applying IQR, which means interquartile range method. I will not take you to the Jupyter notebook in this video. Rather, it is important that you should understand the concept first and application later. So, in this video, you will learn the concept, which will be followed by another video where we will be applying the IQR method on our data set in our Jupyter notebook. So stay tuned for our next video. Once you will develop the concept, you will understand the theory part of it, then you can move ahead with our next video, which will take you to the application of dataset using Jupyter Notebook.
So let's understand the concept of outliers and interquartile range. So the first concept is outliers. So outliers refers to those data points which are basically highly deviated from the rest of your data, which in turn may affect the overall result of your statistical analysis, and therefore it is imperative to identify those outliers and clean your data set and make it free from any such outliers which is going to affect your result likewise. So the method of interquartile range, let's understand first that what does it mean. Now quartile means that when you section out the whole data set into different quarters, which means 25, 50, 75, and final one is 100. So your whole 100% is divided into 25 each. So this methods provide to measure the dispersion of the central part of your data and help us to gain more insights to minimize the occurrences or the presence of extreme value which may distort your results. So here is a data set, and it will be the same data set that I will be using for running the same in my Jupyter. So here is a data set which belongs to 20 normal adults, and the variables that we have captured is weight. So you can see right from 5 to 780. These are the respective weights of all of those participants in the purpose of study. And the units of these weights are in kgs. Now, the reason why I have highlighted the first two and last three is that this is not normal. So any normal adult cannot have a weight of 5 kgs or of 10 kgs, or a normal adult cannot be of 780, 590, or even 400 kgs of weight. Therefore, visually inspected, we can make it out that there is some problem in my data set. There is a presence of an outliers, and let's see how to remove these outliers using the interquartile method. So we have to understand that what is this method all about. So the first rule towards the IQR calculation is to find out the median. In order to calculate the median, the first process is to sort out the data into either ascending or descending order and find out the middle value. Out of my total observation, which is 20 in numbers, so I have segregated 9 in each cluster, which has left basically 10th and 11th observation, for which I am going to calculate the median. So here is the median. You can say that it's a summation of those two middle values divided by 2. And my median is basically 74. Median happens to be the 50 percentile. And then I need to calculate my 25th percentile. How to calculate that? So you can see that 25 by 10, which symbolizes the 25th quartile of my total data set, multiplied by n plus 1. Total number of observation is 20 plus 1, which has given me the figure of 5.25. This Q1 symbolizes the position. 5.21 means that 5 and odd figures. So here I can see 1, 2, 3, 4, 5. So I have reached in terms of 5 on the name of the participant as Eugene. So my values will be lying somewhere in between Eugene weight and Firdaus weight. That's why where my Q1 values will be lying. So this means I have to calculate here 25th percentile, and let's see how do we do this calculation. So next you can see that value of my Q1 is between the values of 57 which belongs to Eugene and 60 kgs which belong to Firdaus, and by interpolation we can calculate our value 59.25. What is that 59.25 means? It means that 25% of the sample out of my 100% data set, the values, the figures there in those are less than 59.25. Similarly, in our next slide, we will just look into it, that how to calculate the 75th percentile. So here I can see that I have the values of Q3, and I have highlighted those values Q3, and I can very easily find that out, that where lies this value. So here is a way of finding out the values. So Q3, which happens to be the 75th percentile, so the values is coming as 15.75 position. So 15.75 positions means that right from here I have to come here till 15th, where the name of a participant is Om. So my values are lying somewhere between 88 to 90, which means in between 15th and 16th position of my data set. Again, by interpolation, I have calculated this value, which stand as 88.5. So this is the way in which we have calculated the value of Qn and Q3. And our interquartile range is basically the difference between Q3 and Q1. So let's have a look here, that what does this percentile basically stands for. It's very useful tool in terms of a data analysis, which help us to understand the whole distribution of a data in my data set. Now here you can see that I have basically categorized all of my data into different quarters. So I have 25th percentile, I have 50th percentile, which happens to be the median, and I have 75th percentile. Here I can see the minimum values, and I can see the other extreme side maximum values. And if you pay attention, what is this 59.25, which happens to be my 25th percentile value? It means that all the observation in this category are basically less than the value of 59.25. So this is what it means. Secondly, here if I just pay attention, what does this Q3 means? If I have the value of 75th percentile value of Q3 as 88.5, it means that 75% of the sample in my data set have the values which is less than 88.5. So we are going to see exactly the same data set in Jupyter, and we will be looking into that how to run the data set, calculating IQR, identifying outliers, and cleaning up your data in Jupyter. To please follow my next video to understand the application of IQR and identifying outliers.